out. I have introduced Jim Ski. Annette Cowie is lead author in the chapter on land degradation. That's chapter 4. Minal had an overall coordination work to do, very tough. She was in the technical support unit. The technical support unit is divided between the UK and India for this special report on climate change and land. Alicia Mirzabaev was the coordinating lead author for the chapter on desertification in this special report. Lindsay Stringer was lead author in the chapter on land degradation, chapter 4, and Jagdish, sorry, I have to look up your name, Krishna Swami was coordinating lead author on chapter 7 on policy responses and instruments. We only have 15 minutes time left, and I would like you to please pose your questions to the panelists. Please don't be shy if you're not a native English speaker. I'm also not a native English speaker. Pose your questions. If they're in French, we'll find ways to translate them. So I see somebody in that corner, please.
Hello, good morning. I have this question about the near-term action. Do you have evidence on field or some experience demonstrating the well-being on near-term positive effect? Have you some example on the world about benefits of this type of action? Thanks.
So who would like to answer that question? Elisha, please, go ahead.
Thank you. Can you hear me?
Yes.
So thank you very much for this question. So this near-term action, yeah, can you? So this evidence on near-term actions and its benefits that I mentioned, like economic profitability of sustainable land management practices, land restoration activities, there were many case studies from the field, for example, under the Economics of Land Degradation Initiative, which showed that land restoration activities can have these returns in terms of overall ecosystem services. $1 invested, $3 to $6 of return. But we need to take into account that these are both provisioning, so-called food and fiber, but also non-provisioning ecosystem services. When we talk only about the food part, it's about half of that, 50% of that. So still considerable return. And then when you look at all the microeconomic evidence on adoption of specific SLM technologies and what kind of impact it had on farm profits, both by many studies on that. I could also refer to you to the WOCAT database, which documented some of these technological impacts. There we can see that many of these technologies are economically profitable. But then, if I may, we could just answer why they are not adopted, because of the many barriers that we talked about, like lack of access to markets, lack of land tenure security, and other things.
Thank you. Thank you. Any more questions, please? Yes, Anke?
Yes, thank you for this very interesting presentation. I have a question for Annette. On the LDN, you had this slide with all the countries that adopted, I think, the LDN concept. I'm not sure that's the right language, but I saw that, like the US and the EU, it was all blank. Do you know the reason for that? Could you explain?
Yeah, that's an interesting thing that you possibly noticed on my map, that 122 countries have agreed to adopt LDN targets, and these are almost all developing countries. Italy is an exception because they were part of a pilot initially. Germany is, I understand, contemplating an LDN target, but generally the answer has been that many developed countries already are undertaking various actions and have various processes, and so it's been a bit of a negotiation to introduce the concept of LDN to their existing processes and for them to consider it. So that's where we're up to at the moment, and there are many developed countries who are saying, oh, that sounds interesting, we should investigate it, and Australia is one of them, luckily. So we're hoping that the developed countries will take it on, but largely because it's been introduced through the UNCCD's process with the global mechanism assisting developing countries to understand LDN and to go through the target setting process. That's why it has been developing countries today.
Good morning. My name is Sujit. I'm from Cambodia. I'm quite interested to discuss a bit more on biochar. My question is that how much CO2 equivalent for 1 ton of biochar? Thank you.
I think that one comes to me as I've been writing most of the text on biochar that's in the report. Biochar can be made out of almost any type of biomass. It's a pyrolysis process, which means heating biomass under a low oxygen environment. And the net energy output, the pyrolysis process releases heat. It releases some biochar, solid product, and also possibly some bio oil. And the net energy output from the pyrolysis process depends a lot on the moisture content of the biomass going in. So if you're to use something quite wet, then you'll have a low energy output. And if you're using something like wood waste, you have a high energy output. The total life cycle impacts of biochar are greatest when you use the heat energy to displace fossil fuel, when you use the biomass efficiently to make the biochar, when you ensure that the gases emitted are captured and utilised, right? And you don't have any methane being produced. And when you use the biochar in cases where it is the most beneficial, which is where biochar is applied to degraded soils, where it has a liming effect, so you displace lime, where it enhances nutrient use efficiency, so can displace nitrogen fertiliser. And we've also found that in many cases biochar dramatically reduces nitrous oxide emissions, nitrous oxide being about 300 times worse than carbon dioxide. So if you can reduce nitrous oxide, that's also very beneficial. So the net climate effects of biochar can be very positive if you have all those things ticked. We have data if you're interested later.
Yeah. Good morning, everyone. My name is Larwanu Muhammad. I'm coming from Niger. I have a specific question to the last presenter. On your presentation, you presented some criteria for monitoring the magnitude of impacts. I would like to know what are the social and ecological factors or indicators you did consider in determining this criteria. Thank you very much.
Are you talking about the figure where we are showing the turquoise and the orange? Just a clarification, yes. So just to clarify that IPCC doesn't do its own research, we assess literature. So we've looked at all these papers which were showing positive and negative impacts, and so this literature assesses. So if you have, like, for example, substantial literature indicating the positive benefits of a particular intervention, it would be shaded turquoise. And for each of these interventions, we would measure on different indicators. So for example, for food security, it would be million people impacted. For adaptation also, it will be measured in people. But for mitigation, it will be tons of greenhouse gas emissions reduced. And for desertification and land degradation, it will be million square kilometers of area that's benefited. So it's a synthesis of a large amount of literature. I don't know if you got the answer to your question.
So I would hear me? Okay. So I would like to pose a question now to Jagdish and then to Lindsay. Jagdish, you were the coordinating lead author for the Chapter 7, which worked on policy support instruments. So I would like to know from you, what policy responses did you find which could incentivize actions to combat desertification, land degradation, to address food security at the same time without causing too many trade-offs in order to achieve the sustainable development goals, which are under heavy stress now because it's difficult, it's being proven that it's a bit difficult to achieve them. Floor.
Yeah. So when we assessed the literature, we found that they exist from different case studies around the world, a mix of policies that are likely to foster sustainable land management with co-benefits and avoid trade-offs. So, I mean, these basically fall in these categories, following categories. You have, of course, you have regulatory policies, including land use, zoning, and so on. So, which would also help in avoiding certain types of upstream, downstream, or other types of spatial trade-offs, or land sharing and land sparing approaches to sustainable land management and conservation ecosystem services. But you also have voluntary and persuasive instruments. For example, certification of produce that comes from sustainable land management, or for example, even the example we have in India, the soil health card, which is now currently focused more on soil fertility, but if you add, for example, soil organic carbon as one of the indicators of soil health, then it can become an instrument as a persuasive instrument for farmers to adopt. There are also, many voluntary aspects as well, collective action. There's and as well as incentives, for example, for ecosystem services. So a mix of these policies, regulatory, voluntary, persuasive, as well as also risk-sharing mechanisms. For example, insurance and extension services, advisories for farmers in terms of either pest attacks and early warning systems. These are all a suite of policy instruments that will have both short-term as well as long-term, likely to have impacts on fostering sustainable land management with co-benefits for mitigation and adaptation.
Thank you, Jagdish. And now to Lindsay. We have an issue in all science policy interfaces. It's maybe not only the IPCC, it's also the IPBES, it's the UNCCD science policy interface. And we also experienced during the plenary discussions of the past 2 days that people ask us, what role do social scientists play? So I would like to know from you, what role do social scientists play at the science policy interface to develop governance systems which can support the implementation of land degradation neutrality?
Thanks, Marianne. Yeah, it's working now, I think. Let me just unclip this. In terms of I think Jim's part of the presentation highlighted how this IPCC report brought together the various different working groups, and I think it's clear from the kinds of conclusions that are drawn that the report wouldn't have been possible without the participation of social scientists. The climate science is pretty well developed, and we've established what's going on with climate change and the links between climate change and land, but really the management side of things links to people and what people do to the land, the human systems that we've developed and so on. So I think going forward, as we advance solutions, we need aspects like good governance which are fully dependent on understanding the human side of things. So this creates a really a huge role for social scientists going forward, and it's one that the IPCC is certainly open to. I think this time, there were social scientists across all different, I'm looking at Jim now, there were social scientists across all different chapters, I think, and there's increasing appreciation that it's not just about science, it's also about local knowledge and bringing in local knowledge to develop the governance mechanisms that we need. And certainly IPBES has moved forward in that regard by having a special task force on indigenous and local knowledge. So I think these science policy interfaces are more open to the incorporation of social scientists, and it's really become a necessity if we're going to move forward in the future towards the Sustainable Development Goals and beyond.
Thank you. Questions from the audience? We have a new dimension. Klaus?
Thank you very much. I'm Klaus Kellner from South Africa. I want to ask Lindsay a question. and that is about land degradation, more the biophysical aspects. And you know that land degradation is often classified or characterized not only by loss of cover, but also the increase of biomass. So what were the criteria? I haven't read the report. What were the criteria, more or less, that you used to classify land degradation? Thank you.
So within the report, the definition of land degradation that we used was it built from the UNCCD definition and the definition that was used in the IPCC's 5th assessment report. So I'm looking at Annette because Annette was on the definitions team. It was slightly different from the IPBES definition, but it did take into account changes in productivity and land cover, wasn't it?
Yes,
Annette?
and human values, so
Yes.
value to humans, ecological function, and productive capacity. So that means that if you have land that's, for example, invaded by native shrub, that is often perceived to be a decline in value, particularly if it's a decline in its value in terms of livelihoods. And so that would actually count as land degradation. Unfortunately, I had to skip through my presentation very fast. My slide on indicators talked about the 3 global indicators of productivity, land cover, and soil carbon. And as Klaus has pointed out, under those 3 indicators, invasive native scrub might show up as an improvement. But at the bottom of the slide was these words about local verification. And that's very necessary to make sure you don't have something like this as a false positive. And so that land which has changed in the indicators in a way that would normally be interpreted as improvement is checked to make sure that that's the case, exactly for this type of example.
Thank you very much. I would like to inform the audience that our panelists will be available throughout the day. So if you have any more questions, you have full opportunity until this afternoon. My final question goes to Jim. Jim, you as the co-chair of Working Group 3, I think it's maybe the first time that you have brought together and you had to coordinate together with Minal the land community and the climate community. I'll just call these scientists, I'll just classify these scientists like that. What were the challenges and what opportunities do you see in future working together with the land community that is assembled here?
Well, it's very interesting that I wasn't terribly aware of the challenges as we did it. We'd already been through the report on 1.5 degrees, where we had already brought different communities together. And I have to say that bringing these communities together has identified scientific questions that we would never have thought of had we not actually brought the groups together. And I think that's a great platform for the future. So when we go into the full 6th assessment cycle reports, we've got a chapter on AFALU and another cross-sectoral perspectives chapter in Working Group 3, but we're also working very hard at the Working Group 2 and 3 connections and getting, you know, lead authors to cross, bureau members to cross between the different working groups. So I think, you know, it's been a great platform for collaborating in the future. I might also say it's not just the scientists, it's bringing the policymakers and their communities together as well. Because we got some comments on drafts of the summary for policymakers that said, what is this concept, land degradation neutrality? This is jargon, I do not understand this. This was the climate policymakers saying that. And I think by going through this, we've heightened awareness among the different policy-making communities as well, which I think is incredibly important if we're going to move forward to action.
So you see full opportunities for future cooperation with the UNCCD Science Policy Interface, and that's great to hear. Thank you to all panelists for your great job and for the good questions and answers. I would also like to thank the audience. And now I would like to hand over to my colleague, Nicole Barker, who will lead you through the next session.
Good morning. Good morning, everyone. I would like to invite my colleagues for this session 3 on Foundation for a Healthy Planet, the Enabling Environment for LDN, to please come up and have a seat. Thank you, everyone, and we would like to go ahead now and start session 3 on Foundation for a Healthy Planet and Enabling Environment. So what an extraordinary amount of information and talks that we just heard on the IPCC Climate Change and Land Report, and I'd like to thank my colleagues for such a clear explanation of the science that's coming out. So what we're going to be doing now, we're going to be switching gears a little bit, and my colleagues here on the stage, you can see their names, and since we want time to really hear their statements, I won't be doing introductions, but what I would like my colleagues on the stage to do is when you get the mic, briefly introduce yourself, and then each person will have approximately 3-minute statement on the topic that they have expertise in. And for my colleagues on the stage, right here in front, you will see our timer. So someone will be helping you and guiding you and keeping your statements brief so we have time for all of us to interact. So for those of you in the audience, you'll notice that our chairs are no longer linear, and that is by design. They're kind of messy. And so what we're going to be doing after these brief statements is that our panel is going to be posing questions to small groups. So you're going to be introducing yourself, you're going to be forming small groups and having a discussion. So since I am not teaching this week at my university, I thought this would be a really great opportunity to get a little bit in of what I've been missing. So very briefly, I'm Nicole Barger. I am a science policy interface member on the UNCCD, and I will be facilitating this discussion. And what I would like to do is first start out with Jean-Luc Schott and his brief statement on sustainable land management for LDN.
Yes, good morning. So my name is Jean-Luc Schott. I am a UNCCD SPI, and I've got 2 messages to deliver with you, very short one. The first is there is no one-fits-all SLM solution. SLM include a large diversity of practices and approaches: agroecology, conservation agriculture with residues, retention and cover cropping, mixed farming system, agroforestry, precision agriculture, integrated nutrient management, involving the combination of organic and inorganic resources. SLM, when deployed appropriately for given location and situation, can be used to avoid reverse and land degradation and restore degraded land. My second statement is choosing suitable SLM approaches for specific area is supported by information on soil organic carbon. That's it.
Thank you. Excellent. And to our next colleague, Eduardo Mansour, on food security and land degradation neutrality.
Thank you very much. My name is Eduardo Mansour. Thank you for inviting me. I'm the Director of the Land and Water Division at FAO in Rome. Great pleasure to speak to you. I would like to be as brief as Jean-Luc was, but it's a challenge. Let me try to summarize then my brief statement on food security and land degradation neutrality. We are really overwhelmed by the excellent information provided by the previous session on the IPCC London Climate Report. And to produce food for all, to achieve the SDG 2 on zero hunger by 2030, we have to take into account the multiple challenges that agriculture faces. Supply and increased demand for food and other agricultural products are driven by population growth and change in food habits, especially in developing countries. It will result in the need to increase food production by about 50% by 2050. That's the current forecast. Also, agriculture is important to generate jobs and income to contribute to poverty eradication, rural economic growth. And we have to do that ensuring sustainable use and conservation of ecosystem, mitigating the impact of agriculture